minimum 2 questions we will take for today. Okay, so what is the question? Let us take it up first. This is a question where two series of resistances are given to you. Okay, we need to find the total resistance, equivalent resistance, total power, total current. Okay, the question is like this: there is a power source over here. This is the positive terminal, this is the negative terminal, and 15 volt of battery is there, right? And this is supplying a current. This is the source of power into this electrical circuit. Okay, into this electrical circuit there are two combination of parallel circuits. At one point here, let us say here, there are two resistances which are connected in parallel to each other. Then it is closing and the circuit extend like this. Okay, and here into the lower part we have three resistances which are connected into parallel, right? Now, and here into the circuit there is a series. Here we have an ammeter which is used to measure the current. Okay, so this is the circuit in front of you, right? Now we need to find what is the total resistance, and it's also given that this is R1, this is R2, this is R3, this is R4, this is R5, right? I will quickly show you the steps, students, how to solve such questions. Okay, into this question the value, we need to find the equivalent R or equivalent resistance equal to what? This is the first part of the question, right? And the second part of the question is what is the total current or the current into the circuit, current I. What is current, right? And the third part is that what is the total power or the power through what? R1, you need to calculate separately the power through each of the resistances R1, R2, R3, R4 and R5. This is how much. So how to take up such question, students, I will explain you. Okay, I will not go into the calculations, but yes, here the values of R1, R2, R3, R4 and R5 are given as R1 is equal to 5 ohm, R2 is 10 ohm, R3 is 15 ohm, R4 is 20 ohm and R5 is 25 ohm. These are the values which are given to you. My dear friends, here, hi Sunita Patidar, you have doubt. Yes, tell me, what is doubt into this? My dear friend, tell me. You can post into the chat, we will continue, okay? Because other students are here with us. So my dear friend, here we have R1 and R2, and we know the value of R1 is 5 ohm and R total current is your doubt. Okay, perfectly fine. We are going to calculate the total current also, which is the part B of this question, my dear friend. Okay, let us bear with me for a few minutes. You will see the steps. Okay, what is the equivalent resistance? My dear friend, you can see R1 and R2 are connected in parallel, right? You can calculate the equivalent resistance for this, isn't it? For the equivalent resistance, what we will do, calculate the equivalent. Let us say RA is the equivalent resistance of these two parallel combination, and let us say RB is the equivalent resistance for these three parallel combinations, right? Then our circuit will be modified to like this: 15 volt of battery, here we have RA, and here into the lower branch of the circuit we have RB, and the ammeter as it is over here, right? This flowing current is flowing through it. I've taken this question separately for today because yesterday I have seen my video which is uploaded into the live session. That was not very much clear, it was very much blurred. Okay, so my dear friend, this circuit can be written like this or not? Tell me, this circuit can be written as like this or not? Right? This circuit can be simplified like this. How? Calculate the equivalent resistance of R1 and R2. Calculate the equivalent resistance of R3, R4 and R5. If you will tell how, it's very simple. These are parallel combinations. For parallel combinations, you know that equivalent resistance is, for this RA is how much? We can say here RA 1 by RA is equal to 1 by R1 plus 1 by R2, isn't it? 1 by RA plus 1 by R2. And what is the value of R1 and R2? You are knowing it. R1 is 5 ohm, R2 is 10 ohm, right? So just put up the value. So 1 by RA is equal to 1 by 5 plus 1 by 10. So in this way you can calculate RA, right? And what is the value of RB? The same parallel combinations. So 1 by RB is equal to 1 by R3 plus 1 by R4 plus 1 by R5, isn't it? Because R3, R4 and R5, all three are in parallel, my dear friend. You can see here. I am not doing a rocket science. This is very simple. The series and parallel combinations of the resistances, you know it. This is a very simple formula, okay? So from here, if you just put up the value, you get the value of RB. I'm not going into the calculations, I told you, okay? R3, what is the value of R3? 15 ohm, just put it. What is the value of R4? 20 ohm, just put it. What is the value of R5? 25 ohm, just put it. From here you solve it and get the value of RA and RB, right? This is RA and this is RA. This is RB and this is RB, right? In this way we have calculated RA and RB. Now Sunita, as you asked, your current, okay, current into the circuit, okay. So my dear friend, if you know the value of RA, if you know the value of RB, just add it. Why? Because this is into the series. Can't you see that? This RA, no parallel combination or so on, branches are there. This is directly connected through RB into a series. Just add RA and RB. This will give you equivalent resistance, right? So let me squeeze a little. Yes, thank you. So equivalent resistance, we are going to solve the first part of the question, is equal to the value of RA plus RB. This is, in this way we have solved the first part of the question. Equivalent resistance is RA plus RB. This part is solved, right? Now what is your question? The second part, the total current into the circuit. My dear friend Sunita, you know that V is equal to IR. You know the Ohm's law. You know Ohm's law? This is the first part. This is the first part, we have solved it. Right? A. Now go to the second part. What is the, by Ohm's law, you know the V equal to IR? V is equal to I into R. Voltage is directly proportional to current. When you remove the proportionality constant, R will be there. R is the resistance. Now my dear friend, you know the value of R. This is R, right? You know the R, you know the voltage, 15 volt, right? So just apply it over here, na? So I can be written as V by R, right? You know the value of R, you know the value of V, just put it and get the current. Got it? Sunita Patidar 234. You got the current and it will be 15 volt, right, divided by total current, and this R will be there into the, this value will be there into the denominator, and this will give you the total current over here, right? And we have solved the second part of this question. That means We have solved B also, right? Now, the main thing is the third part. The power through each of the resistances R1, R2, R3, R4 and R5, right? So, let me write it. It is asking to write a question. So, let me write it your answer, right? Your answer. Right. So, you have solved resistance, equivalent resistance, you have solved total current. Now, what is the total power through each of the resistances R1, R2, R3, R4, R5? My dear friend, for a parallel combination of circuit, here you can see R1 and R2 are in parallel. So, the voltage across here and here will be same, isn't it? Voltage across here and here, rather than saying here and there, let us write a name over here, A and B, right? Voltage across AB will be the same. If voltage across AB will be the same, then what is the meaning behind this? You know the equivalent resistance of R1 and R2, isn't it? You know the equivalent resistance of R1 and R2, and you know the total current I. This I is calculated, right? This I which is flowing through the current, through the circuit. This I is going through this, going into three branches, then adding over here, then same I is floating over here, same I is going through here, right? So if you know the value of this R1 and R2, which is equal to RA, right? Just multiply this I with RA and get the voltage, right? You get the voltage. If you get the voltage between A and B, that means here we will get the voltage between A and B. This is called VAB. Let us say VAB, voltage between AB. If you get, I hope I am not very much fast, I am able to explain, right? So, my dear friend, here VAB is calculated, isn't it? Let me explain it again. You have calculated the current I, you know the current I. You know the equivalent resistance of R1 and R2, which we have calculated RA from here. Okay? Okay. So if RA is known, multiply this with I to get VAB. VAB can be calculated very easily. How? VAB is nothing but I into RA, right? I into RA. You know the value of I. You know the value of RA. How? This is I. We have calculated. This is RA. Just put these values over here and get the value of VAB. And power across R1. Power. Let us calculate the third part of the question. What is the power? Power across R1, PR1, let me write, is equal to VA square by R. And what is the V? VAB. That means voltage across these 2 points. This is A, this is B, and VAB is this voltage. Right? Right? The same voltage VAB through R1 through R2. Right? And power equal to VA square by R. So write the value of VAB square. That is VA square. VA square divided by R. So if you are going to calculate the power across R1, into the denominator R1 will be there, right? And what is the value of R1? 5. You know the value of VAB, you know the value of R1. आ गया ना? You get the value of power. This much of what is the power through R1. This is calculated, right? Similarly, power through R2. Power through R2. This was for R1, and through R2. For R2 also the same voltage will be applied, VAB, isn't it? Because R1 and R2 are connected in parallel. And we have calculated VAB over here, VAB, right? So just write VAB whole square divided by R2. What is the value of R2? R2 is 10, nothing more. 10 ohm. छोटा सा ही तो है, छोटा सा रेजिस्टेंस है, ठीक है. दिस इज वेरी स्मॉल. सो VAB square by R2 equal to 10. Just solve it. You'll get the power across R2. So we have solved power, we have calculated power through R1, power through R2. What is power through R3, R4 and R5? Mind it, my dear friend. This is the point where you need to halt. Halt your mind. Hold the horses, right? Here you can see the voltage VAB will not be the voltage across R3, R4 and R5. Then what is the voltage across R3, R4 and R5? Common question to you. Isn't it coming into your mind? What is the voltage across R3, R4 and R5? VAB was okay for R1 and R2. But what for here? My dear friend, let us say this is C. This point is C and this point is D. Okay. I think I'm not very much, it's not very much congested, but yes, I think it's visible to you. If the voltage, let me explore it like this. If voltage across C and D is like this, the same voltage, and let me write the name of this voltage, let me write, if VAB was there, VCD is there, right? Let me write VCD, right? If the voltage between C and D is V of CD, this one, then same voltage will be applied across R3, same voltage will be across R4, and same voltage will be across R5, isn't it? My God, see this, R3, R4 and R5 all are in parallel, yeah. All these are in parallel. If R3, R4 and R5 are in parallel, then the voltage across C and D, if it is VCD, then VCD is the voltage across R3, VCD is the voltage across R4, and VCD is the voltage across R5. Isn't it? VCD is the voltage across R3, R4 and R5 all. So what is the power? What is the power for R3? It's VCD whole square. That is the voltage across CD. V square by R. The same formula, yaar. V square by R. And here, if you want to go calculate the power across R3, put up the value of R over here into the denominator. This is 15. But we have not calculated VCD. Oh, I thought you did it, yaar, but you didn't perform it. Anyway, let me solve it. You did it. Okay, then you can put up your answer into the question answer section here, right? What is VCD? As we have calculated VAB is equal to I into RA, we have calculated this, isn't it? We have calculated this. So similarly, VCD, voltage between C and D, is calculated as I will be the same current is flowing through the circuit, is equal to I into what? RB. RB. This is your answer. I into RB. I have to squeeze a little. Screen a little much. Yeah. I think it's visible to you now. Into RB. So this is the voltage across CD. Current into RB. What is RB? RB is this one here. This is RB. Right? This is RB. From here you calculated it. And if VCD is identified, then definitely V square by R, power across R3. Then again, power across R3 is this one. And power across, let me give a line between here. Okay. And the power across R4 is nothing but VCD whole square by R. Power equal to V square by R. You remember it, na? So VCD you have already calculated I into RB. Take a square of this divided by R4. Put up the value of R4. R4 is nothing but 20 ohm. Okay, this much of wattage. All this is in watt power, right? All the units are watt, right? This is the power across R1, power across R2, power across R3, power across R4. Now our last one is the power across R5, which you are going to calculate. This was R5. Okay, this was R5. This is equal to VCD whole square divided by R5, and R5 is nothing but it's equal to 25 ohm. You can see here. So put up the value of 25. Okay. So when you solve it, you know the value of VCD. Just square it and divide it by the value of 25 ohm. You will get the power across R5. Power across resistor R5, right? This way we have calculated the power across R5. So we have calculated power across R1, power across R2, power across R3, power across R4, power across R5. R4 was this one, right? This was R4, this was R5, this was R3, this was R2, this was R1, right? In this way we have solved the third part of the question, my dear friend. We have calculated all the powers through all the resistances which are shown into this circuit. Into this circuit, two parallel pair are there. In one pair, R1 and R2 are connected in parallel. In another pair, R3, R4 and R5 are connected into parallel. How to calculate the total equivalent resistance? We have seen it. How to calculate the total current? We have seen the steps. How to calculate the power through R1, R2, R3, R4, R5 separately? We have seen it. Okay. How to calculate what is VAB? VAB is the voltage between this one. The same VAB will be applied across R1 and R2. And here VCD. VCD is nothing but here you can see this is the voltage across R3, R4 and R5, right? So we have calculated it and solved this question, my dear friends. Thank you so much for watching. Take care. See you. Bye bye.